there and welcome to the FONK Explained video. LAMP stack web applications help the internet absolutely explode by providing an easily understood design pattern that enabled choice at multiple levels. We continue to see its influence today even in microservices implementations like the classic Kubernetes guestbook application, which granted doesn't use MySQL, but that just shows how flexible LAMP is as a design pattern. But when viewed in 100 millisecond time slices and in aggregate across many applications that might be sharing the same Kubernetes cluster in a sizable organization, is this really the best way to write applications anymore, given the tremendous waste in resources a server daemon really is? Here's what I mean. Suppose you scaled down guestbook as small as possible. You'd still have 3 server daemons doing mostly nothing except under heavy load out of a 24-hour day. And if you had 10 similarly constructed applications being managed together, now you have 30 processes mostly doing nothing. Wouldn't it be better if those applications could share resources for common components? Most applications have static assets like HTML, CSS, and JavaScript that could centrally be served up by an auto-scaled static server. Those assets get loaded in a browser and make RESTful API calls back to get dynamic content, which are then backed by create, read, update, delete, and list operations, commonly referred to as CRUDL, although guestbook only has the C and the L. And those all interact with a NoSQL store. In fact, you can implement a web application using exactly these self-scaling features on AWS, using S3 for the static assets, and a combination of API Gateway, Lambda, and Dynamo for the dynamic operations. And it ends up being a lot less code and configuration to manage, and no containers for you to actively worry about at all. However, you do pay for those time-to-market gains in the form of vendor lock-in. But what if you had something like a LAMP stack that utilized serverless concepts, but on top of Kubernetes? You'd have less code and configuration for similar results. There'd be less for new engineers to learn, so more of them could quickly take part. You'd have fewer containers to actively worry about, and by extension, a smaller attack surface from a security perspective, and the whole thing would be portable thanks to Kubernetes. That would make a whole lot of audiences happy, from product owners to developers to admins to security architects and even finance. Well, that's what FONK is. It's a design pattern, a serverless LAMP stack for Kubernetes. So a FAS runtime, an object store, a NoSQL server, all on top of Kubernetes. So this becomes this, where here you see Minio offering the object storage, one of the 4 FAS runtimes that is installable on top of Kubernetes that have more than 3,000 GitHub stars right now, providing the API gateway and the function support, and a MongoDB providing the NoSQL store. Just like LAMP, you can mix and match other choices here, but those are the fundamental components of the design pattern. So what is FONK Apps I/O then? 2 things really. We're a collection of community-curated and increasingly complex FONK example applications so that people can quickly learn and use this design pattern. The idea is to build out examples for every FAS runtime in every language that each one supports, so that no matter what combination you want to use, you have a place to start. For people who are as excited about this design pattern as we are, we also provide a set of tools that helps you present FONK at your local meetup or your favorite conference, so we can build a bigger community together. We'll even do our best to help you promote your presentation so that we can all get the word out. Come join us at github.com/fonk-apps.